Assalamualaikum and very good afternoon to Dr. Nur Hidayah. My name is Amir Farhan. So my presentation is about types of compressors in a phase change process and its working principle. The method that I got from this assignment is a phase change process, and then I will explain. And then in a phase change process, compressor is one of the main component. And in this assignment, I will explain the types of compressors in a phase change process, and I will explain its working principle. So, to start off, uh, the function of compressor is that it draws in the low pressure vapor, compresses it, and discharges it as a high pressure vapor before the high pressure vapor flows into the evaporator. That is the normal cycle in a refrigeration cycle. That is the normal steps in a refrigeration cycle. And then compressor is the heart of a refrigeration system, where it is one of the four main components. And there are five types of compressors, and I will be explaining every each of these compressor and also its working principle. So the first type of compressor is reciprocating compressor. The second is rotary compressor, scroll, screw, and centrifugal. So the first one is reciprocating compressor, where compression occurs due to the reciprocating motion of pistons that draws in the low pressure refrigerant vapor. So reciprocating here refers to the back and forth motion in a straight line to the action of a crankshaft and connecting rods. So when piston moves downward, it draws in the refrigerant from the intake valve and into the cylinder. And then the piston moves upward to compress the refrigerant until reach an optimum or desired pressure before the vapor is pushed into the output. So the right figure over here is what I've mentioned earlier. So the low pressure vapor will flow into the cylinder from the intake valve, and this is due to the motion of piston moving downwards. So low pressure here, and then the piston here will move upward to create a high pressure region where it compresses the refrigerant vapor, and then until it has reached an optimum pressure, it will move the high pressure vapor into the exhaust valve. So the second is rotary compressor. So rotary compressor or rotating vane are commonly applied for small scale refrigerant application. And then there are two types of rotary compressor, which are rotating vane rotary and stationary blade. So I will explain first the rotating vane. So rotating vane compressor comes either two blades or eight blades, where both of these have similar working principle, where the vanes or the region create or the blades creates pockets between the rotor and the cylinder wall, and then the low pressure vapor drawn from the suction line into the space, compressed and pushed to the exhaust line. So this is a figure of 8 and also 2 vane rotary compressor. So the blue region here represents the low pressure vapor, while the red region here represents the high pressure vapor, the compressed vapor. So the low pressure vapor flows into the rotary vane, and then the rotary vane will will rotate as it will compresses the low pressure vapor into a high pressure vapor, and then it will discharge to the exhaust valve. So the same working principle for two vane rotary compressor, where or two blades. So the second type of rotary is stationary blade compressor, where stationary blade compressor consists of four working principles. Okay, first is that where this compressor utilizes the eccentric shaft that rotates the rotor in a cylinder. So the first step is that the first step here is that the rotor is rolled against the cylinder of the wall, and the blade trap the refrigerant vapor between the cylinder and rotor. So and then as the rotor rotates, it compresses the low pressure vapor as the space is getting smaller and smaller, and thus the high temperature and pressure vapor disposed via the exhaust valve here. So from the right figure over here, so the low pressure vapor enters the compressor, and then the stationary blade will rotate against among the wall, and then it will uh, compress the compress the low pressure vapor, and then the low pressure will turn into high pressure vapor, and then the high pressure vapor will discharge to the exhaust valve. So the third type is scroll compressor, where in a scroll compressor it have two scroll or two main components that is fundamental for this compressor to work properly. So the first one is fixed scroll and orbiting scroll. So from the figure right over here, fixed scroll is represented by this gray line over here, this gray line of steel or component, while the orbiting scroll is represented by this green line over here. So the function between these two scrolls is that the fixed scroll is fixed to the compressor housing where it does not rotate and remains stationary, while the orbiting scroll rotates in an eccentric path at the center of the fixed scroll. So and then between these two scrolls there is a space known as pockets, where this is where the region where vapor compression would occur. So the working mechanism is here is that the refrigerant will enter the outer pockets between the two scrolls, which is the fixed and orbiting scroll, and it will fill the pockets. And then the orbiting scroll seals up the pocket as it rotates. And then as it rotates, the pockets will get smaller and thus compress the refrigerant vapor. And thus it will turn into a high pressure vapor. And then the high pressure vapor will discharge through the discharge port located at the center of the scroll. So the fourth one here is a screw compressor, where screw compressor uses a pair of special helical rotors to trap and compress the refrigerant vapor as it rotates in a cylindrical compressor machine. So to elaborate more, so from the right figure over here, inside the compressor, there are two types of rotors with different shape. So the first rotor is rotor A. So the rotor A is called a male rotor where it has four lobes, while the other rotor is called rotor B where it is called a female rotor and has six interface lobes. And then both of these rotor will mesh, and then the function of this rotor B, it will drive the male rotor, and both of these rotor is located enclosed by a cylinder C, which is the compressor casing. So the working mechanism is that as the low pressure vapor flows into the suction line over here, it will rotate among these lobes, and then it will be compressed by these two lobes here, rotor A and rotor B, and then it will discharge to the discharge line. The last one here is a centrifugal compressor, where a centrifugal compressor consists of a rotor operated impeller that comes with the blades inside a spiral shaped casing. So to explain more is that through the working mechanism where the low vapor will flow into the casing that is located near at the center of the compressor here, the blue region over here, and then the impeller inside the casing will spin rapidly, represented by this yellow circle over here, and then the vapor is flung out in the casing that causes the compression. And then as the rotor spin, it flings out the refrigerant vapor at the discharge line, where the vapor is compressed against the casing, where it is compressed against the wall of the casing near at the yellow center. And then inside the compressor, there is a centrifugal force that responsible for throwing the vapor out at the discharge port. And then with this help of the force, it increases the efficiency of the compressor. So the table here summarizes the capacity, the horsepower range for each compressor in terms of horsepower or tons, and also its common application. So we can see here is that reciprocating and screw and centrifugal is commonly used as commercial air conditioning, while rotary is mainly used for domestic refrigeration, and scroll here is mainly used as a residential air conditioning, where it's commonly used in household application. And then we can see is that centrifugal is mainly used for commercial air conditioning, where it is usually used in shopping malls, shopping complex, shops, and so on. So that is my presentation about this topic. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.